All right, new day, new laptop to repair, and this time we have an XPS 17. This is the 9720 edition, so a 2022 model. The customer said they bought this thing new in 2022, and then recently went to upgrade the RAM to 64 gigs of RAM, and then now the laptop won't turn on. And after working with the tech for many hours, they determined that it's probably a bad BIOS, but it's giving a 3.5 error code, the light blink code. So I haven't looked at this yet. We're gonna look at it together and see if we can get this figured out. All right, the first thing we'll do is we'll just see if it turns on. And I'm pressing the power button. I'm not getting any lights on the keyboard or anything like that. Let's plug in the power. Keep an eye on the power meter here. Here we go. All right, so it's negotiating 20 volts. The way a USB-C charger works is it will start at 5 volts, it will talk to the laptop, and then it will negotiate up to 20 volts. And then that 20 volts will go into the system and power the main power rail, which on this machine I think is like a 12.6 power rail, 12.6 volts on that power rail, which is the same as battery voltage. But what we're looking at here is you see the amps here. We have 0.08 amps being pulled. What we're looking for actually is we want 0.02, 0.01, somewhere around there, and that means that the EC chip is coming on, the LDO, which is a linear voltage regulator. It's a 3.3 volt regulator that comes on when the laptop's off, and that powers the EC chip, the embedded controller, which is just a microcontroller that runs a loop of code that's checking for power button presses and keyboard presses and things like that. So what we're getting here is 0.08, which is more than we should be getting right now. So we may have a short on the board. We may have a, I mean, they're saying bad BIOS. I don't know. It could be that it's trying to start up the BIOS and the EC programming is messed up. It could be something like that. Let's press the power button and see what it does. All right, we're getting nothing here. At this point, I have no idea what's going on. We're gonna have to open it up and take a look inside, so let's do that. All right, we are missing a screw right there already. All right, this bottom's coming off very easy, so definitely people have been in here. Remember how on these XPSs, the bottoms are on there, they're like snapped on and they're very hard to get off. You have to use pry tools to get in here, but it just fell off. So, you know, we've worked on these in the past and we've noticed that people damaged something when they opened it, and that might be the case. So it may have nothing to do with him actually installing the RAM, but more that something got damaged on the edge of the board. So remember, sometimes taking the heatsink off, it damages something. Sometimes prying in the sides here, it damages a component, it rips it off the board. So we're gonna take a closer look under the microscope in a minute, but what I just wanna examine is some of the things that I'm already noticing. We're missing a screw here. This is just the bracket that holds the LCD ribbon cable down. So we're missing a screw there. We have, it looks like a rusty screw here. I don't know if it's just a different color head or something, but it's rusty looking. That's the wrong screw there, wrong screw there. So this thing has probably been taken apart and put back together many times. He said he did have it with a tech, and the tech working on it for a while, trying to get it figured out. I'm gonna probably end up having to pull this motherboard out, but the first thing I wanna do, let's plug in the power and let's just see how far that goes. We do have the battery charge circuit right here, but the rest of it's on the other side. So we can actually measure battery voltage right there, and I can do that right now. I just wanna see what charge we have on the battery. And the battery is at 0, okay. So first thing I want to do is let me switch out this battery with a charged battery, and then we can test to see if the laptop will turn on. All right, I have a test battery here. Remember, we specialize in Dell and Alienware laptops exclusively, so I have about 700,000 parts back there in my warehouse. And if you need any parts for your laptop, you can go and order it on our website. Everything comes with a year warranty, and it's all going to be a genuine Dell OEM with a serial number on it. So I just went and grabbed one of our test batteries that we have, because we have a test machine for every single model that Dell makes. And this one's pre-charged already, so I can just plug it in. All right, so when I press the power button. Did we see a flash here for a second? Thought I saw a flash there. Let me plug in the charger, see if it does anything different. 0.08, still sitting at 0.08, pressing power button. All right, so we have something catastrophically wrong with this board. Could be a BIOS issue, I don't know yet. I'm not thinking it's a BIOS issue yet. Usually the way I determine if it's a BIOS issue is that we have all of our power rails up and running. So on these machines, you're gonna have the main 20 volts going in, and then that will be reduced down to the main power rail voltage, which would be battery voltage. And on this machine, it's gonna be a 12.6 volt power rail, or a 13, somewhere around there. So the main power rail will be there, be 13 volts, and then that's gonna be powering all the rest of the power rails. So we have a 5 volt power rail. We'll have a 3.3, we'll have a 1.8, we'll have a 1.2, we'll have a 1.05, and then you'll have CPU and GPU power rails. But mainly, if I can see the 3 and the 5 and the 1.05 and the 1.2, then usually if all of those are present, then we can go to BIOS as being an issue. We don't know right now because I can't measure anything. I can only, the 3 and 5s are actually on the edge here, so we can measure those. But everything else is on the other side, so we're gonna have to take the board out to measure that. But let's measure to see if the 3 and 5 are there at least. And on this board, there's actually a 3 and 5 volt on either side. So they have it set up where these inductors are gonna be the outputs of the 3 volt and the 5 volt. So let's measure there. So we have a 5 volt power rail. We have a 3.3, what's this other one? A 2, I was gonna say a 2.2, 5.0. So there's another 5 on that side, and then we check on this side. We got nothing, wait. We got a 5, and then we have 3.3. So we do have the 3 and the 5 volt power rails present, so that's a good thing. That can be one step closer to it being a BIOS issue. Again, we won't know until we take everything out. So let me go ahead and remove the board, and then that way we can just kind of look at it and do a physical inspection, make sure we don't have any ripped components anywhere, and then measure for the rest of those power rails. If it's a BIOS issue, then we'll go and flash the BIOS real quick. So let me get the board removed. And while I'm getting this board removed, this would be a perfect time to hit the subscribe button if you are enjoying the content I'm making. It does take a lot of work to put these videos together, and I hopefully you are enjoying me sharing my knowledge with you. So I appreciate you smashing that button for me, please. I did notice there are a few more screws missing on the fans. There's actually supposed to be 3 screws here. These are 2 of kind of the standard screws that uses everywhere. These are 2 special screws, and that's probably why they couldn't put them back in, because they probably lost them or didn't know where they went. So when I put this thing back together, I'll be replacing all the screws with the factory screws, so this thing will be like it's brand new from the factory. So, all right, I don't know, I've kind of ran into something kind of weird going on here. Let me get on the microscope. So I'm trying to pull this board out, and it's kind of stuck here, and I don't see another screw, right? The fan goes across here and the screw goes in here, but I'm not seeing another screw, and it's kind of stuck here. But then I started noticing something right here. Look at that. What is this? Not the foam. What's behind this foam? I don't know what that is. What do you guys think this is? Is the screw behind that? I mean, it feels like it's stuck there. It's calcified or corroded. I know what it is. It's just a post, isn't it? Sometimes it's like a post that goes through the board and the board just kind of lines up the board. There must have been some water or liquid in here because that thing is stuck on there. What do you guys think? Yeah, you can kind of see the board goes through this and this pops through. I don't think it's a screw. I just think it's a post, an alignment post. Sometimes they have that. And I wonder if someone's been trying to grab onto it. Or someone glued something in here. The board does not want to come out. I mean, I just worked on one of these. The last machine I worked on was a 9700. A very similar board to this. And it did not have this issue. Should we put some pliers on it, I guess? I don't know what it is. Okay. It's just disintegrating when I grab it. Let's clean it off with alcohol and see what it looks like. I don't know what it is. It's almost like it was a screw. Here, let me grab a test board so we can see what's supposed to be on that spot. All right, so here's, I think this is one. So here's that area. Let me pull this sticker off. All right, so it is just a hole through the board, right? And I think there must be a post that the keyboard uses as an alignment area. I don't know if there's another one anywhere else. But in any regard, I guess we can just break that part off or something like that. I don't know why it's so big or oversized. Let me see what I can do to get it off. Maybe we can cut it off. Some side cutters. I don't want to scratch the board. This is just a ground plane that's hooked to anyway, so we don't have to be too careful, but... Oh, you know what? I wonder if someone's soldered. That kind of looks like solder. What do you think? Huh. That'd be funny if someone soldered right there. Let's see what a soldering iron will do. This is definitely a first, you guys. Okay, let's see. Ready? No, it's not solder. So I feel like it would be melting by now. Okay. Well, I guess I'll just keep trimming away at it. The last thing you want is to break the board, right? Because we're about to fix the board. I know the board's already broken, so how can I break it more? Well, this is how you break it more, if you just rip it out. But I don't really know how I'm supposed to get the rest of that out of there without damaging the board. Oh, it's coming. It's coming. Oh, there we go. Whew. What the? That was nuts. I have no clue. I mean, we're about to see what's going on under this. What the hell? I mean, it's very corroded. I mean, they may live near the ocean or something like that. Let me check. Yeah, they live in Cancun. They live in Cancun. So I guess so. All right, well, we'll clean that up. We'll try to make it where the board will go back in there easily. But I suspect that this probably has something to do with the issues with the board. Because if we're already seeing signs of water damage or liquid damage or humidity or corrosion or whatever it is, then definitely we'll have some other problems. And I can actually notice that the board looks dirty. It almost looks like someone cleaned it. That's kind of what it looks like. It looks like someone scrubbed it with a toothbrush or something like that to try to get corrosion off. You know, the real way to do it is to put it in ultrasonic cleaner, and that would clean everything off. So, all right, we got the board out. Now it's time to do the physical inspection. That first part of the physical inspection failed. So I guess I'll take the heatsink off too. Oh, my goodness. Okay. Another thing I just noticed, I'll zoom in. So this heatsink has 7 screws, right? 1, 2, 3, 4, 5, 6, 7. They're all labeled. So these 2 are missing. Well, I actually took these screws out, but they were just regular screws. And normally there would be these special spring screws that go in here, like this. Normally there should be these little spring screws going in these holes. Well, there was just regular screws in these holes. And on this particular model of laptop, you have to take the heatsink off to access these screws that actually hold the motherboard in. Well, I didn't need to because those screws are already missing, and they just had screws through here to hold the motherboard in, but they were regular screws, they weren't the real screws. So we'll have to replace these screws with the real ones too. So there's a lot of weird stuff going on here, and I'm already not looking forward to this because it may just be going down a rabbit hole, but at least you're there with me. You get to enjoy it too. All right. How's the thermal compound doing? Not a drop. We don't have a single drop, which is fine. I mean, I know they've been working on it. It's busted, so they probably cleaned it off and didn't worry about putting anything back on, but yeah. So we know somebody's been in here that much. All right, physical inspection time, the boring part. All right, so we'll start over here. So remember, on the edges is what we're gonna be really paying attention to. If they were using pry tools to open the bottom, that's where they rip off components. All right, so we got the VRAM. This is the VRAM for the GPU. There's the LCD connector and camera connector, backlight connector. Looks like someone's been doing some soldering over here. So this chip was probably replaced, it looks like. More flux. Whoever worked on this, and they're diagnosing it as a BIOS issue, and then it's a 3.5. We actually should look up what the 3.5 is. 3.5, I think, is a power rail failure on this machine, so we should look that up. I think it depends on what you look it up as. Sometimes it will come up as a BIOS issue if it's a 3.5 on some machines, and then it's a 3.5 as a power rail failure on other machines. All right, Wi-Fi card. All right, we're gonna go to the edge of the board. There's our fun little hole that we dealt with. The rabbit hole, since we're going down the rabbit hole, that was the starting. So now we just went down that rabbit hole, and why are we even working on this machine? It's so messed up. And if I don't fix it, I don't get paid. So all my time here is gonna be wasted if I'm having to go down this long rabbit hole, so. All right. That's the battery connector. We get some more flux here, like someone's been changing out stuff over here. 3 and 5 volt power rails were up and running, remember? This is the power management chip. This is what controls the charging of the battery and stuff. These are the RAM modules. Okay, so let's flip it over. Again, we're going to look at the edge of the board. Really pay attention to anything, any place a screwdriver can go. Got some Kapton tape here. I can't remember if that's factory or not. Got a little bit discoloration on these. Looks okay. I mean, all of this is so dirty. It looks like someone's like scrubbed it with a toothbrush and alcohol, which kind of smears around all the flux. Okay, I don't see anything there. Let's go back to this side. I don't want to miss anything because then I already know that this one's going to be a pain in the butt. So, all right. So here, I'm going to start on this edge. Sorry, I'm jumping around a lot, but all right. So we're going to walk our way around this edge. We got a missing component here. That will cause this issue. It's all ripped off, all the pads. And this would be that tool, you know, sticking your tool in the side. So can we fix this? Let's see. We can attach here. We're going to attach here. That is okay. This one's okay. This one is the only one that we may not be able to reattach to. We got to figure out what that one's supposed to be attached to. So, but that would definitely cause the machine not to come on or give a power rail failure. Okay, we're going to keep an eye out for anything else. Kind of looks a little corrosion-y here. Not too bad. I kind of want to ultrasonic cleaner this before I even work on it because it's so dirty. Okay, going across here. There's a component missing here, but it probably is supposed to be missing. Sometimes they don't populate different areas. Yeah, so I have, here's my other board, same. Not a big deal. That's the BIOS chip. Somebody's taken it off and put it back on multiple times. Is it a BIOS issue? I don't know. Maybe it's that ripped component on the edge of the board. There's the EC chip. Could have an EC chip issue at this point too. The BIOS programs the EC chip on this one, so you don't have to pre-program it, but it's there's an EC region in the BIOS whenever we flash that. But I don't think it's a BIOS issue at this point, so. All right. We've almost made it all the way around. Okay, is this broken? The edge of that chip looks broken off to me. What about you? See, these are all square, and that's broken off on the edge. What do you think? Let's compare to our test board. Test board. What do we think? Another tool went in here, boom. So we have to replace that too. I don't know. This is looking like a rabbit hole. If I can save this computer, you guys better give me a thumbs up because I am not looking forward to this. The fact that somebody else has worked on it, you know, that's what makes it tougher in general. And then you have things like these broken chips, rip traces, and then someone's already been messing with the BIOS. So sure, I know how to write the BIOS, no problem. I can put a brand new BIOS on there, it'd be good to go. So I don't have to really think about like, oh, is the BIOS gonna work or not? I don't, you know, who cares? I can put a new one on there. That broken chip and then the missing chip with all the traces, and I'm gonna have to like add new pads and all this stuff. That's gonna take some time. And then is it gonna turn on at the end? I don't know. I don't know. And then I'm gonna definitely put it through the ultrasonic cleaner because this thing is disgusting. What should we do first? Probably rebuild that pad over there and those traces and then put that new chip on there. I guess so. Let's do it. Here's your problem. I mean, it's, well, let me look up at 3.5 real quick. Let's do that actually. XPS 9720 light codes. If anyone wants to figure out how to find them. And here we go. All right, so They said it's a 3.5. I never saw a 3.5. We didn't see any power at all, actually, right? But they're saying BIOS issue, but it clearly is a power failure. All right, so did we decide we're gonna do this chip first? I don't wanna. I mean, somebody's been over here messing with it. It seems like they would make a note going, and there's a chip ripped off the board. But instead they're gonna be like, I don't know what's wrong with it. I just changed the RAM out. All right, here's my board. Oh, yeah, that's funny. So this is my donor board or whatever. Look, I've already stolen that chip because this is the same chip that someone ripped off when they opened it. I'm telling you, taking that bottom off and just ramming your tools in there. Oh my goodness. Okay, this one has a hole in the board, which is funny. I'm not sure. I got to look up what that chip is to see if it's the same as this other one, because I might just be able to take that one and put it there too. But I'll have to rebuild the traces first. But I kind of want to look and see where the traces go on here. And since we already have it off, that works out. All right, so this one's coming right here. It goes through here and comes around over here somewhere. So we should be able to tie into right there. This one ties in over here. This one ties in there. That one ties in there. This is a no pop here, no population, which is missing on here. So, because I was wondering what would go here. So we're going to replace this, and then this pad's good. We'll have to replace that pad, that pad, that pad, and that pad. We could tie in, oh gosh, it's ripped all the way around here. But we could tie in right there for this one. We can tie in right there for this one. What else? Let me clean this off so we can see this better. Do we have anything else missing in this area? All right, that's much better. Much easier to see. All right, there's nothing there. I don't think it's supposed to be anything there. Yeah. All right, so the only thing we should have is 2 resistors and then this component right here. All the rest of that stuff is missing. So we have our 2 resistors, and then these pads. So we'll have to rebuild that one, that one, that one. So I'm gonna take this off first, and then we will add a new pad that goes all the way across there, and then we can put a new one on, and then we can do the pad there. All right, I know I keep talking about it, and I haven't started. I just am dreading it, that's why. So let's do it. All right, I'm just gonna take that resistor off first. Okay. I'll save it just in case, but I don't think we need it. I don't even know what value it is, but okay. So then now we'll need to scratch away some of this. So we have something to solder to. Good. Scratch away at this. This is already kind of opened up, like someone was already messing with this. And then that one's already opened up. Okay. And then this one, we should be able to just solder right across there. I'll just clean that up just a little bit. Okay, let's get this party started. Here are the traces I'm using. It's just a pack that I actually bought from Northridge Fix, and it's a miscellaneous pack that has a few different sizes and shapes. So what we're gonna look for is something that will get us close to the right size. So it's not a circle, it's gonna be the rectangular. This isn't gonna carry a bunch of current or anything, so I'm not worried about it being super large. I think that's gonna be the one we're gonna have to use. It's gonna be a little small. You see how many traces I've replaced. Okay, we'll start with just one of these. So we decided on this one. All right, here's my finger so you can see how big it is. Isn't that crazy? So I think we're gonna do this one first, right here. So we're gonna line this up. Actually, I need to put some solder on these, all these spots first real quick. Little flux. Just dabbing some solder on these spots. I don't want a big pile, I'm just trying to get a little bit on there. Okay. All right, let me see if I can get this lined up better. Like a surgeon, down the rabbit hole we go. Gotta get that bend just right. It doesn't have to be perfect. We're just trying to get the pad in the right spot, and we need to be able to get it soldered. So, all right, let me just tack that on with some solder. All right, let's do the other ones, and then we'll put some new solder mask on everything to hold it in place. Okay, number 2. I know I'm kind of making it look easy. It's not very easy. I had one machine I worked on that had 13 chips ripped off the board, and I had to rebuild a lot of those. I have a couple videos on that. The thing is that, yeah, this is a lot of effort, and is it worth it? Well, of course. This board right here is a probably an $800 board. And I charge $250 to fix these motherboards, so. Can I straighten that out a little bit? Yeah, it's all right. All right, let's get that last one in there. All right, we have them all in place. The problem is I have all this flux on here. Normally I don't like having tons of flux because I'm about to try to put that solder mask on here to hold them in place after that. I still don't like this one. There we go, that's much better. Okay, so I need to try to get some of this flux off of here without breaking these off, and the odds are that I'm gonna break one off, but we're gonna just try to gently roll on some of this. This is isopropyl alcohol. I'm just going to try to get some of this flux out of here. So let's dry that a little bit. Nice. Okay. All right, so solder mask. Again, I bought this at Northridge Fix a while ago. This big bottle, I only use a drop, like a tiny little drop. So this will last you forever. I take a little piece of tissue because I'm just going to throw this in the trash when I'm done. And I put one little drop on it. Boop. That's actually too much. That's a huge drop. It looks tiny, but it's huge. And then I'm going to use a pair of tweezers that I don't give a crap about. These old Hackos. All right, so the idea is you just are going to dip one side in, and that might even be too much. Just get a little bit on there. And then you'll come over and we're just going to touch it. Let me move this one back out of the way. We're going to break the extras off at the end. So right now I'm just going to try to cover up this stuff here. So you see how much I put on there? It's just not very much on the tip, but it's a lot on here. And we're just trying to line that up. Okay. I'm not even adding any more. I just did that one little dip. There we go. And I may need to add just a little bit. And if we get any on top of a pad, it's not a big deal because you can just scrape it off when it dries. But we're just trying to, you know, I may end up adding, yeah, maybe let me just put some down in here too, just that way we can hold it in place and we can scrape it off when we're done. So I'm just going to cover this whole thing actually. We'll cover this whole thing and then we'll scrape off after we dry it. And that way those will stay in place better. Okay, I'm going to separate these wires because we're going to be breaking off the end of the wires shortly. Okay. All right, so the last thing. So now what we do is we move this out of the way so we don't touch it on accident. It gets on our clothes and then or on our face and we don't know it and it's been there all day long. I'll use a UV curing light. Again, I got this at Northridge. It runs for about, I don't know, 30 seconds or something. So I'm going to put it on there and I'm going to do a few cycles and just let that run. And I'm going to wipe off the end of my crappy tweezers so I don't have to worry about it getting on anything. So I'm going to run through 3 cycles of this and then I'll be right back. All right, so we went through 3 cycles of that, of the UV curing light. So now it should be nice and hard. We'll go ahead and hit it with hot air a little bit too, and that will harden it up the rest of the way. But as you can see, it is hard. So I'll just heat it up one more time just to make sure we're good. Yeah, I do see some stuff underneath there a little bit boiling. It might just be a little bit of flux that was down in there. So that's good. So I did verify that this chip and this chip are the same. So I can actually take that other chip off the donor board and we'll move that over. We will need to clean this off. So we'll need to get that cleaned off. Good. This cleaned off. Oh, don't bend. No, no, don't do that. No, no, no. Don't do that. Okay, that cleaned off. And this. Just be careful. Be careful. Okay. Just a happy little pad. We do need these broken off. These tweezers are at the end of its life. Okay, let's grab another pair. Okay. Good. The last one. Okay. So, oh, someone still have something there? Okay, so we're good there. Let's just add some solder to these pads and then we can transfer that chip over. And that resistor, right? We forgot about this one, didn't we? Okay. So we got to be extra careful, right? Because we don't want to have to start over. So I'm just going to dab these with some fresh solder. There we go. Boom, boom, boom. Okay. All right, so let's get the chip transferred over and then we'll put the resistor on. All right. I'm gonna rotate this around. Get in the right orientation. Gotta be so careful with this, right? We're gonna be very careful. We're gonna go in, we're gonna get in there and get out of there really fast. Ah, the chip flew away. No! The ninth dimension. Okay, here we go. Try not to put too much heat here. I don't want those pads to get messed up. I don't want to try to move around too much. Okay, we're on. It is connected. Now we just need to get this resistor connected here. So I'm going to apply some pressure. Okay. All right, let's get that resistor on, which should be fun because it's tiny. Tiny, tiny, tiny. I think it's an 0201. All right. Can we do it without it flying away is the question. Okay. And we'll just hit it one more time with some hot air. All right. Everything looks good. What do you think? Did we do a good job? Okay, okay. Yeah, I guess I should have covered up this too, huh? What do you think? Since we have all our solder mask stuff out, we'll go ahead and put some stuff on that too. That's the smallest drop and it's huge. Let me wipe some off. So I'm telling you, it doesn't take much. Oh, okay. Good. Here we can add some more on here while we're at it. Just for good measure. I'll hit with the UV light and we'll come right back. All right, we got that all cured. We'll do one last cleanup here. All right, looks pretty good. All right, so the big question is, will it work? Of course it will. I'm just gonna plug it in. We're gonna look at the power meter. We just wanna see it start pulling some current. I'm gonna feel the CPU and GPU. So my fingers are on it. And 0.9. No, it's not going anywhere. Okay, so it's not working. But remember, they messed with the BIOS on this thing, so we're gonna have to put a new BIOS on here. And let me see if I have one already made. Otherwise, we'll have to make one. So let me check that real quick. Okay, I don't have one made, so you guys get to sit through me making one, which can be exciting or not, I don't know. So let's go ahead and do that. First thing we'll do is, I don't know how their BIOS is, if it's any good. Actually, let me check. Let's see if Bad Caps have one, so I don't have to make one. It's a long, drawn-out process, so. All right, well, Bad Caps doesn't even have one. So yeah, we're definitely have to make one. So my plan is to just rip the BIOS off of this one, because it should be the same board, I think it was, right? What's the board part number? Yeah, so it has the same board part number. So this is gonna be the same BIOS, but we'll need to rip the BIOS contents on here, but it's actually programmed to run on this serial number of board. So we'll have to do a reset on the actual BIOS firmware. So we'll be editing it, and then we'll be able to create one that we can put back on this other board. So let me show you how I do that. So we're gonna use a chip reader like this, and then I have, these are like a little pogo pen, little adapter, and it's made to fit on a 6x8 chip, and this one has a 6x8 BIOS chip. Where's it at? Right. Oh my goodness. It's missing because I'd already stolen the chip off here, so I actually don't have a BIOS on here to actually take. I feel like I would have a backup of it then. That's interesting. Let me check to see if I have a backup of it already. Okay, I don't have a backup, but I did find another board. So this one is the same. This one just doesn't have the AMD graphics on it, but that should be fine because we're gonna reset all that part too. What we're gonna do is gonna extract the BIOS contents off of here. And so what we do, this is a pogo pen reader, and we're gonna line it up on the chip itself. And so this is a Giga device, and it's 25R, oh, nope, I'm gonna take this chip off. If it's a 512 like this, you see how it says 25R 512? 512 is a 64 meg chip, and they take forever to read, and having to hold a pogo pen reader on that takes forever. So we're gonna actually remove this chip, we're gonna put it into a reader, and then we'll read the device that way. All right, we got it off. So now instead of using this pogo pen reader, we're gonna use one of these devices, and it's just a little housing, and you can put the chip in there. And we need to put it in this orientation. Good, and then we need to remember what the chip number is. So 512ME. All right, so we have it in there like that. All right, I'm gonna pull up the reading software here, and we need to start by detecting it. So we're gonna detect it. It detected it, and what did we say it was? ME, right? Yeah, so, and it's gonna be a WSON 8, so we're gonna select that, and we're gonna go ahead and read the contents on that. And it actually reads faster than it writes. So you see how slow it is to read right now? If we were gonna write to it, it takes about 8 or 10 minutes. So, and if you have the pogo pen, you would have to hold it down in place, and it just, if you move just the slightest, then it errors out and you have to start over. So for anything that's a 512, I don't do it. 256s, I can do it. So we got that read. I'm gonna verify it, so we're gonna read it twice. We always wanna make sure that the contents did read correctly. Sometimes we have to slow down the frequency that we are reading. This reader actually reads pretty fast at 30 megahertz, but you can change it to 15 and 8 megahertz if it's having issues reading. All right, so let's save that. And I always name the original one original. Isn't that original? All right, here's what we're gonna do. We're gonna use our ME analyzer, and if you guys want any of this software, I can't give it to you, can't tell you where to get it, you can just search for it yourself. So ME analyzer is an open source project, just type that in. Then we are going to take that file that we extracted, and we're going to drop it into ME analyzer, and that will analyze it. And what that's gonna do, I just wanna make sure there's no errors here. File, that may be an issue. There's the GitHub link if you want a copy of this ME analyzer, but we'll see. Okay, so the main point of this ME analyzer will actually analyze the ME region of this BIOS. It says this is version 16.1.35. It says that it's already been initialized. So if you have a ME that's already been initialized, it means it's initialized to that device that's on. I can't just take this BIOS and put it on another device or else it won't work. So we have to put this in configured mode. And then this is the flash tool that we're gonna need to use to fix that. So we're gonna open 16.1.25 flash tool, or just 16.1. So let's do that. So we have our, where's that? Okay, flash tools, and we need to go to 16.1. And Not it. All right, so 16.1, and we're going to open our flash tool. Let me actually delete the rest of these out of here because I've been working on other ones. Okay, so we're going to start with nothing in here. Okay, we're opening it. So here's the flash tool. We're going to drop that same extracted file in there, if I can find it. Here it is. So we're going to drop that in here. And what that's going to do is it's going to decompose the file. So there is an error on this. So this one has a bad BIOS too. So when you see an error like this, that means that the BIOS is actually corrupted. It has a parsing issue. We could try using 16.0. Let's try that real quick just in case. So sometimes 16.0 will work instead. Yeah, we still have a parse error. So I think that BIOS that's on that motherboard is no good. So let me see if I can find another BIOS. I mean, I guess we could just extract theirs and try to fix theirs, but I don't know what they did to it. So it's hard to know. Let's go ahead and extract theirs, I guess. All right, I removed their chip off the board. I saved you from having to see that. And it was this chip right here. So we'll go ahead and read their contents. Maybe they didn't mess with the BIOS much at all. I mean, they took it off, put it back on. I don't know if they flashed some BIOSes that they found on the internet. I don't know. So I don't know what's on this chip and whether it's going to have a bad file system just like the other chip did. But what ends up happening is you have a corrupted BIOS or you have a corrupted file system. These things are made, for 512 is the bits, but it's actually 64 megabytes is the size. But the BIOS region itself is only like, see, we had a bad read. So that's why we do a verify. So let's do a read again. Okay, I'll make sure this is pushed in here really good. So the BIOS region is actually only like half of the size of the whole BIOS chip itself, and then the rest of it's going to be like the EC region. There's going to be an ME region. There's a bunch of different spots in there. So like when we extract a BIOS, you'll see it split up into a bunch of different things. So it's not just the BIOS or UEFI. All right, that was a successful read. Let me save it, and we'll name that original. I'll put the repair number on it. Okay, so now let's see if let's open that in ME Analyzer real quick and see if we have any errors. All right, there was no errors in this one. So looks like the file system's fine on that one, so that's good. And this one still uses the same tool. This one's initialized, but it's actually using Flash Tool 16.0 versus the ME version is 16.1, but the tool is 16.0. So that's what we're going to use to open that file. So let's go do that. So I have 16.0 pulled up. And then, yeah, so we're going to drag it on there. And it still failed. Okay, well, let's try 16.1 now. I've actually had bad luck with 16.0. 16.1. That one errored out too. Oh my goodness. Okay, I'm gonna have to hunt around and see if I can find a good BIOS. I might have to pull a board from stock or something like that and then I don't want to do that because those are new boards, so I hate pulling chips off. If I could just read it, that'd be something different. It's hard to read them in line on the board. So let me look around, see if I can find a BIOS, and then we can continue. All right, here's what I decided to do. So I took that BIOS chip that we took off the other board and put it on this board. I just wanted to see if it would actually try to turn on. And so we plug it in, and look at the power meter. Look, 0.1, and then look, we got 1 amp. and the CPU is getting hot. So it is trying to come on. Now, I know for a fact because it is a different board, the ME region is not set to this board, it should give us a bad BIOS error, but we might be able to boot into recovery after that and be able to flash the BIOS. So that's what we're gonna try to do next. So now that we have the board turning on, I'm gonna have to put the heatsink back on. We're gonna have to partially assemble it so we can try that out. So let me do that next. All right, I got the motherboard installed. Let's see if this thing turns on. All right, and 1 amp, we got the Dell screen. Look at that. Boy, but the odds are we're gonna get a error code here. It's probably gonna be, let's look up what those error codes are real quick. Yeah, I'm not sure what the error code is gonna be, but we're gonna let it sit here and go through this startup process. It's doing a CMOS reset since the battery's been out the whole time. And it is the wrong BIOS that's on here, so we'll see if it will work. It's actually the correct BIOS, but just the wrong ME region. So we'll see if it actually works, which I doubt it will. All right, while this is sitting here, it hasn't moved yet. We're gonna see if we can prepare the system to do a BIOS recovery. And so we'll just download this RCV file again, which will download this. What? Wait a minute, guys. Look what just happened. Look what just came up. Ha! Cray cray. Okay, well, I did not think that was gonna work. Does the keyboard hooked up? I don't even have the keyboard hooked up. All right, let me turn it back off. I'm gonna hook up the keyboard. Okay, we are getting a blink code now. 4.1, that's a battery missing, not installed, that's fine. Okay, let's try it again. Keyboard's installed, our keyboard's hooked up. Let's go into the BIOS. I still want to do a full BIOS recovery flash on this. That way we can get this back to factory on this machine. Still taking a while. It shouldn't take this long to turn on. All right, well, while that's booting up, go back to this. Okay, so we're gonna copy this onto our flash drive. This is a special BIOS recovery file, and then we'll put that into our machine and we'll hold down a special key combination to have it boot straight into recovery. We're gonna have to install the battery real quick, actually, too. You can't flash a BIOS without a battery installed, so. And it is charging the battery, the charge light's on. Well, that's awesome. Okay. So let me turn it back off. I don't want it on while I'm gonna go into this recovery mode. Okay, so I have the file on this flash drive. I'm gonna stick it in there. I'm gonna hold Control and Escape at the same time. I'm gonna hit the power button. And that should boot us into BIOS recovery. And we'll just let it sit there. All right, so I got to the BIOS recovery screen. I've selected our file, and we're just gonna go ahead and update that. And that way we can get this BIOS configured properly to this machine. I'm actually surprised that it worked. I've never seen where I could just take a BIOS chip and move it over. It should have actually threw an error code, but I'm not complaining. One less thing to deal with. We did go down a rabbit hole on this one already, so it looks like everything's working at this point. I'm able to get into the BIOS and I'm able to charge the battery. It's trying to boot off a hard drive. I don't have a hard drive in there, so we're gonna let this BIOS update run and then we'll come right back. All right, BIOS successfully updated. So now it's rebooting. All right, we got the Dell screen. What I want to do next is actually boot into diagnostics. It seems like everything is working, but we don't know, we actually need to run full diagnostics to test all the other devices. There's a couple other parts I need to install, plug in, and make sure everything is attached before we run full diagnostics. So let me do that real quick. All right, I got everything else plugged in. Now we're gonna boot into diagnostics and run those real quick. All right, I'm seeing a few issues with the system still. So I have a test hard drive installed, it says no hard drive installed. And every time I turn on the system, it hangs. It sits there and takes a long time to get past this Dell screen. The hard drive is detected in the BIOS here. So if we look, so you can see that it's a 512 drive, so it's actually detected in here. The video card, it's not showing up. So we have it starting slow, hard drive's detected, but it won't boot off of it. And then we have the video card is not showing up, the discrete video card, the NVIDIA. One thing we did notice when we were looking at this board is that we did notice that there was a component that had been changed out on the GPU. I'm assuming that they were messing with that, so that's probably why that graphics card is not going to work. And I don't know how much of the rabbit hole we want to go down trying to fix that. The machine is functioning, except that now we need to figure out why it's not booting off the hard drive. Remember that one chip on the other side of the board that has a crack in it? We'll change that chip out and see if that fixes it. But well, we're going to have to keep kind of looking at different things, but it may be a lost cause at this point because there were so many people working on this machine, and I don't know how much more time I want to put in this. I have about 2 hours into this so far, so let me go ahead and get this board pulled back out so we can continue. All right, I got the motherboard out, and I'm starting to think that all these issues are actually related because the hard drive is actually not getting any power at all. So it's not heating up. I can tell it's not getting any voltage to the drive itself. And taking a long time starting up might have to do with it's trying to check certain things and it's not seeing that. And then maybe even the video card is not getting the voltage it needs. So we need to figure out why this power rail is missing. I don't know if it's going to be that chip that's like half broken. That's over in the area where like the Thunderbolt controllers are. So it's going to be part of that system, which is part of the USB-C. So I don't think it has to do with that. I mean, we'll still change that out. Actually, I'm going to keep this on so we don't get thermal paste everywhere. Let's just plug this in. Let's get under a microscope. What powers the drive? I'm not really sure where all that comes from. We'll measure it over here on this side. So that's the power management IC right there. And so this is all going to be 13 volts stuff. So this is all going to be what actually charges and runs the machine. Oh, we're missing a component right there. We missed that one earlier, didn't we? Is it a resistor or a capacitor? If it's a capacitor, it's not really doing anything. Let's look at our test board. It's just a capacitor. So we can put a new one of those on, but it's not going to change anything. Let's see. Let's make sure nothing else is ripped off any of these resistors, since we know that somebody has been being a little rough on this machine. Because if a resistor is missing, then the machine will not turn on. That is very, very easy. You could just have this little guy come off, and then now this won't turn on anymore. But a capacitor is not a big deal. They just act as filters for the most part. All right. Again, why is there flux over here? I mean, I don't understand what these people have been doing to this machine. It looks like they took this BIOS chip off. This isn't really a BIOS chip. It is a BIOS chip, but it's for like the USB-C controller, probably. So we got to figure out what's powering the hard drive. It's probably going to be on this side. So here's where that broken chip is. Where's it at? Right here. It's just chipped on the side. So I'm not 100% that that's even having an issue. I don't even know what these chips do. But we need to be very vigilant on any missing components in this area. Any resistors. I mean, all this has been reflowed. All that's been reflowed. I mean, this is all extra solder. So I don't know if... I don't know. See, is that burnt? That kind of looks burnt. Sometimes when you look at a resistor, you can see it's burnt by it being like a little circle hole on it. Let's see. Nah, that's fine. You would see like a little dot. You'd see a dot right in the middle of it. That looks okay. Sometimes it's hard to tell if something's missing if someone's resoldered it, because you can tell if it's been just ripped off, because the pad will look different. See, I mean, you see all the solder balls on these things? I mean, I don't know. I should have not even worked on this. Because, yeah, I have this thing working. There's the BIOS chip I put on. I have the thing working, partially working. But, I mean, somebody's messed with this so much that it's hard to go back if you don't know what somebody else has done to it. All right, let me see if I can figure out where the power comes from for the hard drive. All right, I'm pretty sure the power for the SSDs are going to be coming from this area right here. And there's another one on this side. Well, this is a little different setup on this side, so maybe it's all getting power on the other side. Because these are the Thunderbolt controllers. There's the BIOS for the Thunderbolt. There's the audio. This EC chip really bothers me that there's all this flux around here. Granted, it could be flux coming from the BIOS chip area and coming over here, but I don't like that. And it could be, yeah, I'm thinking it's this right here, this U7001. Let's plug in the board and measure right there. Oh, something else I just saw. Look at the heatsink. It's like green. You like that? So this laptop doesn't deserve to be fixed. It's pretty messed up. Okay, we're gonna measure right here, right? So what we're gonna be testing for is we wanna make sure we're getting our 13 volts there, and then we're gonna measure to see if we're getting our output voltage. So we'll wait for the board to turn on. Once the board hit 1 amp, okay, the board's on. So now we just wanna see if we have, we have 3.3 there, 3.3 there. What does this chip do? It's been soldered before. 3.3, 3.3. Yeah, maybe this isn't the area. We have all the 3.3 here. Let's measure on the hard drive itself. On the SSD itself, all right? Hey, we got 1.8 volts there. Okay, so we are getting some voltage on here. We got 0.9 there. Got 1.8 there. Let's measure some capacitors over here. Got 1.8, so the actual drive does have power. 2.5, so it's not a power issue. This isn't energized right here. I don't know what we're supposed to have here. We do have 1.8, so I don't know if this is supposed to also get a 3.3. I haven't seen a 3.3 on here yet. So some of these lines aren't powered on. So it might be a combination. And this is 20 volts over here, so straight from the charger before it goes into the power management chip. But we have to kind of figure out what voltages we're supposed to have on that drive. Let's look at this area. 3.3, 3.3. I mean, I don't know what I'm looking for. The thing is that because somebody's been in here messing with it so much, they've really made it hard for anybody to fix this. Maybe that was the challenge. All right, I'm actually starting to think that this chip right here goes to the SSD. And so this right here could have something to do with this. We have a couple inductors here, which are the output or the input of a power rail coming in here. And when I measure here, I'm getting different readings each time. So let me go ahead and just change this chip out since we know that that's physically damaged, and see if that resolves the issue. That would be make it a lot easier, and we can move on. So let me get that changed out. All right, we got it off. Let me grab the one off the donor board real quick. All right, we have installed it. Is it gonna fix the issue? I have no clue. I'm thinking it is that area. I'm thinking that could be a possibility. I'm about to take a break, go to lunch. I actually have a haircut, and then I'll come back. I'll have shorter hair, and hopefully I can finish this up. But before we do that, let's try this. All right, I'm gonna quickly install it in the machine, and we'll see if we can get the hard drive to detect. All right, I forgot to turn the camera back on, but I did test it, still not working. So I'm gonna take a break, I'll be back, and we can try to continue this repair. At this point, you know, there's just one thing after another, and we have it partially working, have it booting up. It's just not detecting the hard drive, and it's acting a little strange. But if they would have just sent it to me right when it broke, then I would have been able to fix it, no problem. But now, because I'm trying to fix all the things they broke, it's just a nightmare. All right, I went to lunch, got a haircut. Now I can continue working on this. I've been thinking about it a lot, and I've spent so much time on this machine already, and I feel like it's a lost cause. But what's interesting is I just turned it on when I got back from lunch, and it booted right up to Windows. So I did, initially we changed out that chip, and I tested the hard drive, and it said the hard drive still was not detected. Well, I still get the hard drive not detected screen error sometimes, but then I just hit enter, and maybe it's saying that it's just not detecting the secondary hard drive. I don't know, because I just hit enter, and then it boots up and boots to Windows. I have a test operating system in there right now, and so everything seems to be working. The only thing that still doesn't work on this machine is the GPU, the NVIDIA GPU. And considering that they had changed out some chips in that area, I'm like, I don't even want to start messing with all that. I'm going to have a conversation with them. I've already spent probably almost 3.5 hours on this thing, which, you know, it is in a functioning state. Everything's working. See, I'm getting this hard drive error still, right? But if I just press enter, and I think it just must be doing it for, there's 2 hard drives in here. There's 2 SSDs in this machine, so I think it must be giving the error for one of the SSDs, because I just hit enter like this, and then it boots right up. There you go, it's booting the Windows. All right, so we made it into our test operating system. This one's Dorothy, is our theme. We name every single one of our test installs. So as you can see, everything's working, and I already been doing Windows updates on this install. It's passed all the stress tests, but that NVIDIA GPU is just not even showing up in here. So I think that there must be something physically wrong with that, especially since they've been messing around in that area. So I'm just gonna let them know that that's not gonna be repairable. But the laptop is up and running, and you came down the rabbit hole with me, and I just wanted to, oh, I'm still installing drivers. I appreciate you guys coming down the rabbit hole with me, and thanks for watching.
I saved another laptop!